Hi class, and welcome to Module 2, Part 2. We're still going to be talking about that normal probability. So our objectives today is to find the probability of a standard normal variable, so a little bit different than Part 1. Identify the differences between normal and standard normal variables. Normalize values. Calculate the probability of standard normal variables, and calculate the z-score given a probability. So with your standard normal distribution, a more specific type of normal distribution is called the standard normal distribution. The standard normal distribution has the following three properties. So the graph is bell-shaped, so very similar to Part 1 when we talked about a normal distribution. Okay, so remember, bell-shaped means that the mean is in the middle. And that, remember, 50% of your data lies to the left of the mean and 50% of your data lies to the right. The mean is equal to 0. So here's what's a little bit different. So with your normal distribution, your mean could take on any value. Same with your standard deviation. Here, your mean is always going to be 0 and your standard deviation is always 1. And then your standard normal variable is represented using the variable z. Okay, so with with your normal distribution, we use the variable x. With the standard normal distribution, we're going to use the variable z. The number of standard deviations from the mean is also called the standard score or z-score. To find the probability of a z-score, so again, that's at your standard normal variable, we need to find the area under the curve, so which corresponds to the probability of that z-score. So again, very similar to what we did with Part 1. If I want to find that probability, I'm finding that area under the curve. Okay, and again, these are set up the same way as the other one. It's just instead of your mean and standard deviation being any number, my mean is always 0 again, and my standard deviation is always 1. Okay, so how you find the probability of a standard normal, okay, distribution. To find the probability of a standard normal variable, z, we're going to use this function here. So again, this is what you'll be putting into your Excel. Use the same methods as before to find the probability. If it's less than or equal to, you just use the function. If it's greater than or equal to, you're going to use 1 minus the normal distribution, and remember that is the less than. And then if it's in between, we find each probability and then we subtract the larger from the smaller. So again, it's very similar to what we did in Part 1. It's just now we're working with a z-score. Okay, so let's go ahead and do a little practice. So I want to find the probability that z is less than or equal to 2.04. Okay, so again, I'm using this equation right here. So I'm going to go ahead and go into my Excel. Okay, and I don't think you guys want to learn about taxes, so I'm going to take that down. Okay, so one thing I'm going to do here is I'm going to actually type in my score, because when you guys do your deliverable, these numbers are going to be in there. Okay, so 2.04. Okay, so now let's go ahead and use that equation. So it's equal, so norm dot s distribution. So then my z-score, well, that's right here. And then again, we're going to go ahead and put true and hit enter. And I have 0.97932. Again, I'm going to want to round to 4 decimal places. So that would be 0.9793. This is equal to 0.9793. And as a percent, it would be 97.93%. Okay, so let's go to the next one. I want to find the probability that z is greater than negative 0.45. So remember, when you're doing this, it's going to be 1 minus the probability that z is less than or equal to negative 0.45. Okay, let's go ahead and go into our Excel. So again, I'm going to do the same thing. I'm just going to go ahead and type in the z-scored number, so negative 0.45. Okay. And now I'm going to go ahead and find the normal distribution. So that's the norm, equals norm dot s. There it is. Okay, so then I'm going to go ahead and here's my z-score. And here is true. Okay. So remember, that one there, okay, so again, I'm going to highlight that for you. That was to the left. We want to the right, so I just got to subtract from 1. So then in this slide over here, because again, we're doing that cell referencing, it's equal to 1 minus, and I'm going to highlight that, and hit enter. And now I have my answer. So I get 0.6736. Rounding to 4 decimals is 0.6736. Which means that is equal to 67.36%. Okay, so let's go ahead and do this one. So I want to find the probability that our z-score is between 0.85 and 2.23. So remember, if you're doing in between, you're going to find the values for both. And then we subtract the bigger from the smaller, okay? So let's go ahead and go and do that. Okay, so again, I'm just going to go ahead and put these z-scores in. So I have 2.23, and I have 0.85. Okay, so now again, I'm just going to go ahead and find the normal distribution for both. Okay, so there's my z-score. Again, always true. I'm going to hit return. Again, do it again. Equals. So you're going to get really good at this by the end of this one. Here's my, oops, here is my z-score. True. And enter. Okay, and then our last step is we want to subtract the bigger from the smaller. So equals, and then again, I'm just going to cell reference. Enter, and there's my answer. So 0.18479, that will round to 0.1848. So this is equal to 0.1848. Which means that this is 18.48%. Okay, so as you can tell, it's very similar to what we did with part 1. Just the difference, we're just using a z-score versus our x. Okay. So what I'd like you to do now is we have an example here. So it's just in word form versus just writing an equation like we kind of did in there. So I'd like you guys to go ahead and pause this video and work it out yourself, and then come back and check it with me. Welcome back. Okay, so let's see how we did. So what is the cumulative area from the left under the curve for a z-score of 1.3? Well, it says the area from the left, so that means P has got to be less than 1.3. Well, let's go ahead and go into our Excel. So I have 1.3, enter. Let's go ahead and find that. So that's equal to my norm. Remember, we're using with the z, so if we want to use .s. Okay, so let's highlight that. Again, always true. And I get 0.9032. Which is 90.32%. let's see how we do the next one. So what is the cumulative area on the right under the curve for a z-score of 1.3? So this one's saying to the right. So remember, if it's to the right, that's going to be 1 minus the probability it was to the left. Okay, well, let's go in. Luckily, we already have that answer. So then to do that, all I have to do is equals 1 minus, make sure I cell reference and hit enter. I get 0.0968. Which is 9.68%. Hopefully you did well on that. If you have questions, feel free to email. And just a review. So, normal distribution, the variable is x. Your mean and standard deviation can be any number. The standard normal distribution, we use a z variable. Our mean is always 0 and our standard deviation is always 1. What they have in common, they're both bell-shaped. Okay, so that means they're symmetric. 50% of the data lies to the left, 50% of your data lies to the right. It's always going to be a continuous variable, and to find the probability, that means we're finding the area under the curve. Okay, so let's go to the next thing, standardizing normal variables. So to convert a normal variable x to a standard normal variable z, we need to use the following formula. So z is equal to x minus mu. Remember, your mu is your population mean divided by sigma, which is your population standard deviation. This is called standardizing and represents the number of standard deviations your value is away from the mean. We call these values your z-score, and you want to round the z-scores to 2 decimal places. Okay, so let's look here. So you take the SAT and score 1100. The mean score for the SAT is 1026, and the standard deviation is 209. What is your z-score? Okay, well, let's look at that information. So you take it, your score is 1100. So that's going to be my x. The mean score is 1026, so that's your mu. And the standard deviation is 209, so that's my sigma. Okay, so let's, oops, well, I wanted to move it over anyway. So z is equal to, so I have 1100 minus 1026, all divided by 209. So let's go ahead and plug that in. When you're using Excel, you want to make sure that on the top you have that parentheses, otherwise your order of operation will create an error. Divided by 209. Okay, so I get 0.354. And we round our z-scores to 2 decimals, so my z value is equal to 0.35. Okay. So let's go to the next one. You have a test score of 190. The test has a mean of 150 and a standard deviation of 25. Assuming a normal distribution, what is your z-score? Okay. Well, let's look. Your score is 190, so that's your x, minus the mean, which is 150, all over our standard deviation of 25. If I plug that in to my Excel, again, make sure you use those parentheses, 190 minus 150 divided by 25. And I get 1.6. Since they want 2 decimals, I'm going to write it as 1.60. Okay. So now I'd actually like you to go ahead and do C and D. So go ahead and practice to see how you do. Welcome back, everyone. Let's check to C. Okay, so for C, the temperature is recorded at 60 airports in a region. The average temperature is 67 with a standard deviation of 5. What is the z-score for a temperature of 68? Okay, so your x is 68 minus the mean of 67, all divided by my standard deviation of 5. When you plug that into Excel, you should get 0.2. So again, my z-score is going to be 0.20. Okay, so let's go to D. So books in the library are found to have an average length of 350 pages with standard deviation of 100. What is the z-score corresponding to a book of length 80? Okay, well, we want to know what's 80, so that's x minus the mean, which is 350, all divided by 100. After plugging that into our Excel, we get negative 2.70. So hopefully you did well on those two examples. So working backwards. So what if instead of getting the z-score and calculating the probability using the normal distribution, we want it in reverse? So what do I mean by that? So let's say that instead we're given the probability and we want to find the z-score. So to find the z-score given the probability, you are going to use this equation right here in your Excel. So one thing to be careful about, to use this function, you need to make sure we are given the probability that the value is less than. If not, you need to subtract the given probability from 1 before plugging it into your formula. Okay, so that's really, really important. So I'm going to make sure that I have this highlighted so you guys see that. So make sure that that is done if it's not less than. Okay, so let's go ahead. So find the z-score if your probability of z is less than z is 0.9032. Okay, so this one is less than, so we can just use the formula. So again, I'm going to go ahead and go in here. And I'm going to go put in my probability. So my probability was 0.9032. Okay, so now I'm going to hit equals. And then we're going to use, so it looks very similar from the beginning, our norm.s. There it is, but we're using the inverse. Okay, now I'm going to go ahead and put in my probability. There's that, and hit enter. So then I get a z-score of 1.3. So my z-score is equal to 1.3. And actually, that should make sense because when we did the z-score of 1.3, we ended up getting that probability in a few questions back. So, yay, yes. So now we want to find the z-score if the probability is greater, if z is greater than or equal to z is 0.6554. Okay. So I'm going to go ahead and do the same thing. I'm going to go ahead and put in this probability, 0.6554. Now, that question was greater than, so the first thing I need to do is I need to subtract from 1. So 1 minus, I have no idea what got hit there. There we go. 1 minus, there we go. Enter. You know what, we're just going to go over here because sometimes Excel is odd. Okay, there we go. I'm just going to go to a new one. Equals 1 minus, there we go. I have no idea what's going on there. What we're going to do, in this case, I'm going to write 0.6554 again. There we go. Equals 1 minus, there we go. No idea what that happened, so this is a good lesson. If sometimes those weird things happen, just start over in a new cell. Okay. So there's my probability. So now we're going to go ahead and use that for our z-score. So equals, or sorry, our probability. So norm.s, here's the inverse, here's my score we want to use, and now I hit enter. Okay, so again, I'm going to make sure I round that. So in this case, z was equal to negative 0.40. Awesome. Okay, so same thing, you guys know what's coming. Go ahead and try these two on your own and come back and check the work with me. Welcome back. So we have from the left, so the probability that z is less than z was equal to 0.3425. Okay, plugging it in, I have my probability 0.3425 equals, okay, norm.s. Again, I'm using that inverse. Here's the probability. Hit enter. I get negative 0.405. So when I round my z-score, you should get an answer of negative 0.41. And that should make sense that it's really close to the one we just did because those probabilities were super close. Okay, so now this one's saying from the right. So if I was writing that, that would look like this. 0.9832. So since it's from the right, okay, remember we have to subtract. So first thing I'm going to do is put in that probability. So 0.9832. Now I'm going to 1 minus. Okay, now we're going to go ahead and put in that. So the norm, here we go. We got our inverse of the probability. Hit enter, and I get negative 2.124. So this z-score here is going to be z is equal to negative 2.12. So just to review, when finding the probability or percentage of a standard normal variable, we use equals the norm.s z true. Your probability is a number between 0 and 1. You want to round to 4 decimal places and then convert to a percentage. If you need to normalize a variable or find the z-score, here is your formula for that. This takes a normal variable and turns it into a standard normal variable, and you want to round to 2 decimal places. Again, that's not going to be a percentage. And sometimes the reason why you would normalize a variable is sometimes people just like working with that versus the normal distribution. They just prefer this method. Sometimes it's more convenient. And then when finding the z-score given a probability, you're going to use this formula here in Excel. Make sure that the probability inputted is for the less than value. If it's greater than, make sure to subtract it from 1 before putting it into the formula. Okay, that is everything. If you have any questions,